Hello students, welcome to another online lecture in operating systems. In this course, we have looked at various concepts and components of operating systems and what make up a typical operating system. And today we are going to look at an example of an operating system and see how these components are integrated into a typical general purpose operating system. And to consider as an example, there are various options for us, but we are going to start with the Linux operating system. So, one of the main reasons why we have chosen Linux as an example is it is a good option to learn, and also given that quite a few of you are commonly using the Windows operating system, it may be good to have exposure to another alternative operating system there. So those are some of the reasons why we are looking at Linux operating system in today's lesson. So this starts with the Unix operating system. Unix was a multi-user multitasking operating system that came about in the 70s. And this was the time where there were mainframe computers, and many users would connect into a single mainframe computer and do or run different tasks at the same time. So they had large computers with larger computing capabilities, at least for that particular time period, and they were able to share that with a number of users. A number of users would share the same computer. So that is sort of the foundation of the Unix operating system, where they had to share these with multiple users to do multiple things. So, as a fundamental requirement, this sharing was there, multiple users was there. So every aspect of the operating system was catering to that particular requirement there. So in terms of design goals for these operating systems, given particularly the Unix operating systems, given the era from there they start, they were primarily designed by programmers, but also for the use of programmers or people who had a much more fundamental understanding of computing and who were able to write their own programs, scripts, and so on. So that is sort of the nature of the users, at least at the initial part of these operating systems. That was the initial goal there. So they had some design goals, or they had some design sort of principles there. One is being simple, being an elegant operating system, having consistent outputs being produced at different points in time, being able to do more powerful tasks, and having the flexibility of being able to use the same operating system in different contexts. So there were a number of these goals were there, but again, this is we have to think about the era and time from where these originated. So those were slightly different as well, considering sort of present day computing. So the initial version was of Unix was from the 70s, or like 69, 70s, and then they came about sort of much more prominently being used throughout the 70s, and then throughout 80s and so on, there were a number of variants, a number of variations of Unix-based operating systems, or BSD operating system. Sun OS came about. So then there were a number of variations came about. And then in the early 90s, the Linux operating system came about. So it was again following the same principles of Unix operating system, but it was a new operating system that came about later on. But in sort of the present day scenario, Linux is one of the most common Unix type operating system that is being used. So when we say a Unix operating system, we talk about the standard Unix. So that is So because of there were a number of variants, different people were developing different variants of these operating systems, there was a necessity to have some interoperability, a common standard to be followed. And that standard is what is called the POSIX standard. So that POSIX standard is something that is followed by most of the Unix type operating systems, including Linux, which is also a POSIX compliant operating system. So that POSIX standard set out certain conditions about what are some of the libraries that should be there, what are some of the commands that should be supported, and so on. So that is the standard. So any operating system that would follow this Unix standard can be considered as a standard Unix operating system, compliant operating system. So Linux is a variant of Unix operating system, and as I said, that is the widely used Unix variant that is being in use today, and it is a particularly dominant operating system when we consider servers. For example, if we consider servers that are catering the internet particularly, a large number of them run on Linux operating systems, and they are also pretty much commonplace in a number of smartphones these days, particularly with Android-based smartphones. Linux can be considered as a base for that operating system as well. And if you remember our discussion about microkernel and monolithic kernel architectures, Linux is a monolithic kernel operating system in that context. And one of the main sort of differentiators with Linux is that it is a free software licensed under the GPL or the GNU public license of open source license. So that enables people to take Linux and modify it in certain ways and redistribute. So there's like a lot of variations of Linux operating systems that you can find. So there's this Linux philosophy, or the even Unix philosophy that we can think about. That is, make each program do one thing and then do that thing as better as it can. And each of the program will output something to another thing. So there's this, we can forward the output of a program as an input to another program. So programs can be designed in that manner. So rather than building one large program that is capable of doing many things, we will build many small programs that can do those things particularly well. So then we can use these tools, use these smaller tools to build more complex tools if we need. So that is one of the, that is sort of the basic philosophy that is behind these type of operating systems. So when we say small programs that do things well, we talk about, say, network related small programs. So when we think about Linux operating system, we would come across these type of various small programs that can do various things. Say, for example, wget can download things or save things from a remote server. NSLOOKUP can do NSLOOKUP pretty much. Ping is a command that is used to check if a connectivity between a server. SSH is for SSH protocol connectivity. So different programs will be there to do different things, and they can do that particular aspect well. Then we have what are called shells, so things like bash or any of these things. So these shells are basically command line interfaces through which we can access a lot of these fundamental system calls. For example, system functionalities can be directly accessed using these shells. Then we can have again another set of small programs like a date or info or manual or echo or these type of small commands. So we can call them commands, but they are in itself are programs that do small programs that do one thing well. So we have quite a variations of these programs. So we can again, how we are going to go about looking into these commands and things in today's lesson is that we are going to be focusing on some of the basic theories today in this lesson, and then there will be additional practical component that will be shared with you via LMS, and you can do some of those activities later on as well. So these are some of the things that again we will revisit them in those some of these practical activities, these small programs that do something well. Then when we think about Linux, the most of the time what you would come across is what is called this Gnu Linux. So this Gnu Linux is basically, Linux is the basic kernel of the operating system, the underlying kernel of the operating system. That is an open source kernel. Then GNU, there are number of utilities that have these things like all these basic small programs will come from GNU. So combining of these two is what we get as GNU Linux operating systems. So there are a number of distributions that we would get, like Ubuntu is a pretty famous distribution, Debian, Linux Mint, Red Hat, and so on. So there's hundreds of variations of Linux distributions, and given the nature of open source nature of this thing, it is because it is possible because of that. So now again, like say we have looked at like kernel structures or underlying operating system structures. If we think about Linux kernel, for example, so this is how these are organized. So we have the IO component, memory management, process management, interrupts at the bottom, and system calls at the top. So system calls are what would be used by other programs, so they will be on the top layer. Then we would have the file systems, memory management, and process management, the three main components of an underlying operating system. And then we would have the interrupts and so on at the bottom. So a typical Linux kernel structure. So then if we think about interfaces to the operating system, so we have system call interfaces, we'll have some library interfaces and user interfaces. So things that are running on the kernel mode can be accessed by the system call interface. So these are relevant to file system, IO system, memory management, process management, and so on. Then the standard libraries that on top of the kernel level, so these are particularly in a GNU Linux operating system, these are the GNU libraries, so they can be accessed through the library interfaces. And then some of the standard utility programs, again some of these can come from GNU, they can be accessed using the user interfaces. So as I said, there are text-based command line interfaces to these operating systems, but in addition to that, it is also possible to have graphical user interfaces based on what is called the X window system. So again, this is something we may have touched upon previously. And by the nature of open source nature of a Linux operating system, there are various options for these X window systems as well. So we can have GNOME or KDE or XFCE, so there are a number of variations that we can have for the graphical user interface part of the Linux operating system. Then the implementation of file systems are something that we have fairly in detail covered when we are discussing about file systems. The root file system, and then the hierarchical file system that we have. So all these things that we have covered when we were discussing file system. So this is just the implementation of that in a Linux operating system. Particularly the two common things that you may recall is the use of, particularly in the context of command line interfaces, we may use a dot to denote current directory and double dot to denote parent directory. So if you want to go to previous directory, we may issue a command of cd and double dot to go to previous directory and so on. So again, some of these things you will cover in the practical component that is part of this particular lesson. So in terms of file types, again, the same things that we have discussed in our file systems lesson. So ordinary files, special files, directory files, all those things are there. And there are certain limitations in terms of how the file names can be, what are sort of type of file names we can have, what are some of the characters that are allowed in files and not allowed in files, and so those variations are there as well. Then there are some common directories that are found in typical Linux file systems. Again, bin for binary or executable programs, devices come under dev, libraries go under lib, usr for user directory. So these typical directories are also common in most Linux systems. Then when we consider directories and files, we looked about index nodes or index-based file systems when we are discussing file systems. So most Linux file systems implement that depending on, because we have different variations of file systems as well, but a variation of that could be found in most Linux operating systems. Then in terms of access control and security, in Linux operating systems, we have the concept of users and user groups. And then we have administrators that identify as super users. And then permissions can be granted to users or groups based on the privileges. So we can do read, write, or execute permissions. We can give them to users or groups. So that is basically what we can do in terms of access control and security. So access permissions can be for read permissions. It will allow to read a file or any resource. Write, X to denote execution. And then each file or resource we can also specify who is the owner of the resource, or if it belongs to a group, or if it is owned by a group, or even if we want to allow access to others. Say, for example, we can say the owner can read and write, people in the group can also read, and others cannot read. Or we can say others can also read. So we can particularly specify who can do what actions under what conditions. So a typical access permission that can be displayed, or you can view using an ls command in a Linux command line, it would specify what are the type of accesses allowed. So it would specify whether it is a directory or a file. Then it would break that into 3 groups. One is for the owner, group, and others. So it would say owner can read and write, others can, group can read, others can read. So the user, the group, the file. So that is a typical permission setting that you can see in terms of access control in a typical Linux operating system. So these permissions can also be defined in terms of binary strings specifying what is allowed or what is not allowed. That is an alternative way of going about these as well. So there are a few variations that we can have there. So you may come across these type of variations symbolized as a 666 or like 3 digits. Instead of binary numbers, it may be given as 3 digits sometimes. Then when we consider the concept of processes in a Linux operating system, again, a lot of the concepts that we discussed when we were discussing about processes and scheduling, there are various implementations for that. Processes can be associated with users or groups. Processes have the ability to open files. They will be associated with a particular directory as their working directory, and they can use a lot of system calls to do various things. And processes can also create other processes, which is one of the basic things that we discuss about process creation and inter-process communication. So creating processes, for example, we can run the command or call the file and run the process. And if you want to run the process in the background, we will use the operator and ampersand at the end of the command to specify what's happening with that. Specify that it should happen in the background. Then we can use jobs or PS commands to view current process statuses. So they may include job number, PIDs, and so on. So these are few commands that can be used for those purposes as well. Then we can use additional commands like FG, BG, kill, and so on, or nice to change priorities, stop processes, moving to background, moving to foreground, and so on. And there are some additional ones for scheduling as well. Again, these things, you will have to try these things from a practical setting. So I am covering these things as an introduction to what are some of the possibilities in a Linux operating system environment, but you will have to cover these things in a practical setting to get a better grip of these things. Then shell is the command line interface to Linux operating systems, and as with any shell interface, there are a number of command line possibilities. Again, one of the main things for your practical activities. Then most Linux operating systems would also implement a number of utility programs. So these are relevant to file manipulation programs. They may have some text processing programs, administration related programs, and so on. So these additional programs, so these are not core programs, these are additional utility programs that may be there to do more things within the operating system environment. Then in terms of file and directory operations, some of the typical commands are present working directories to list what is the current directory that you are located in. Say, for example, if this is the directory you are in, it may be listed as that. So if you do cd, that would change directory to a different directory. So say if we start with present directory this, and then we do cd class, then the present directory would be this. And then if we do cd back again, we may go to home, for example. Then we can do the listing command for listing everything that is in the directory contents of a directory. We can use the L command to list with details. If we just do the ls, it will only list the names. If we do ls -l, it will list everything else. If we do -a, it will also display hidden system files, and if we combine those two as -al, it will do both of those things at once. Then creating a directory, we can use the make directory command, and for removing directory, we can use a remove directory command. Copying files, moving files, again, these are some of the things that you can try when you are doing your command line practical activities. Then removing files, removing individual files, removing files using certain patterns, or removing all files. So be careful if you are using this command, because that would erase everything in a directory. Then in terms of access control, we can change the owner of the file or directory. We can change the group of a file or directory, and we can also change the permission of a file or directory. So what they can do. So by changing these numbers, we can say what they can do in terms of they can say 0 is they don't have any permission, 4 is they can read, execute, read and write. So then this is for owner, group, user. So we will use in that order, and we can change the permissions as well. We can change who is the owner, who is the group, and the particular permissions there. So given Windows is a common operating system that a lot of you would be familiar with on your in a day-to-day use, if we compare these two operating systems, particularly at this point in 2020, these two are fairly sophisticated, and because they have been there for a long period of time, so they are fairly sophisticated, developed operating system. Even though they have some origins in the 70s and 80s, at this point they are capable operating systems that can do many things. But when we compare these two operating systems, again, they are both of them are monolithic kernel operating systems. Even when we discussed kernels of operating system, we said monolithic kernels are fairly common. So in these two operating systems have that. And the core systems, or the core part of the monolithic kernel is can be identified as that. And one of the differences is the user interface, or the graphical user interface, is part of the Windows kernel, whereas in Linux operating system, that is X windowing system, is part of the user space, for example. So there are some differences, but there are some similarities as well. If we think about an application in a Windows operating system environment, the windowing system runs in the kernel mode, whereas in the Linux operating system, the windowing system runs in the user mode. So that is one of the main differences that we can see between these two operating system environments. And even in terms of how they are created, they are written or they are largely written in C programming language, and they are portable in terms of they can run in very different processor architectures, or many different processor architectures. But one of the differences that you may see in the Linux kernel particularly is Linux kernel can be much smaller compared to Windows kernel in terms of memory requirements. So for that reason, Linux may be found in many microcontroller applications as well compared to Windows operating systems. But in sort of many larger operating system environments, Windows is also can be commonly found. Even maybe because Linux is open source, it may be ported to much more hardware platforms than Windows, maybe because it has to be done by a single vendor, whereas Linux may be ported by many vendors, many hardware manufacturers, and so on. Then in terms of complexity and system calls and so on, again, there are a lot of similarities in terms of what they support. Even the present versions of Windows operating systems implement or support a lot of POSIX subsystems, support for a lot of POSIX system calls or equivalent system calls. But given the windowing system is not part of the Linux kernel, it has significantly less number of system calls relevant to that implemented in the kernel. But other than that, both of them are fairly capable operating systems in that sense as well. Then one of the other Linux variants that you would come across, and a lot of you may be familiar with, is an Android operating system that is common in smartphones and tablets these days. And given Linux is an open source operating system, Linux was taken as the foundation of the Android operating system. But then on top of that, it implements quite a lot of variations. So it has its own user interface variations and so on. So the basic structure differs significantly after the kernel level. So it starts with the Linux kernel level at the very bottom, but then beyond that, it has a number of hardware layers, libraries, various framework things, and so on. And those things vary significantly for an Android operating system compared to any other typical Linux operating system. So I would highly urge you all to go through the additional resources that would be shared on LMS, and there are a number of links that you can find on this slide as well. So given this is something that you have to learn by doing, because it's a practical nature of this thing is what we expect you to learn from here, because conceptually the components of Linux operating system, we have covered all of them when we were discussing various components of any operating system, like file systems, process management, scheduling, memory management, and so on. We have discussed them almost in those lessons. So today what we had was just an introduction to Linux operating systems and how these things are put together in an operating system. But I highly urge you to go into these, use these resources, and get a better understanding of Linux operating systems and how to interact with those. And one of the important reasons why you may have to do that is, as I said, Linux is a very common operating system in many server environments and many large-scale computing situations. You may have to use Linux operating system. So your familiarity with Linux operating systems would be a good skill to have. Particularly, many organizations may ask you about, are you familiar with Linux operating system? And being able to do that is a plus point that you will have from an employability point of view as well. So it is a good skill to have. So use some of these resources and get a better understanding of that. So with that, our discussion into operating system lessons conclude. And there will be some additional resources as well that will be shared on LMS. And as always, you can reach me with any questions or doubts. Until we meet in another course another time, thank you for participating in all these online lessons and contributing positively. See you another time. Thanks. Bye.